There's now going to be some very specialized cases that we're going to go through. These have to fit a particular pattern to follow through with this case, and then we'll have to use certain things. We're going to look at something with square roots in it first, and then we're going to move on. And we're actually going to talk about something known as a squeeze theorem, and then look at some cases with squeeze theorem, and those deal with more trigonometry than they do sort of the direct algebra. So we're going to have to see some of those things. So that's where we're headed with this. Number 3. When working with square roots, let me go ahead and write the example down. So give yourself a little bit of space to finish writing this statement, and then we'll write down this example. Let's see if we can do the limit as x approaches 2 of, let's see, the square root of x plus 2 minus, yeah, 2, all divided by x minus 2. So my question is, could I put the 2 into there for x? And if I do that, what does my numerator become if I put the 2 in there for x?
No.
So I put 2 in here. 2 plus 2 is?
4.
Square root of 4 is?
2.
Minus 2 is? Okay. 2 minus 2 is? I get a 0 over 0. We call that an indeterminate form, by the way. In a couple of days we'll talk about that lesson in a little more detail. It's known as an indeterminate form. Is there a common factor that your factoring mind knows to take out of that numerator at the moment? Does it fit any of our factoring patterns that we've dealt with over years? Yeah, no. No, we're kind of out of luck on that one. So, to finish this thought, if we're working with a square root, and it's in a pattern of something like this, where the square root is actually in the numerator, we actually want to do something called rationalize the numerator. And that's going to feel like, oh my goodness, didn't we rationalize denominators back in algebra? And wasn't that our technique in algebra? And now you're telling me I'm going to actually rationalize the numerator? Do we remember how to rationalize something that looks like this? You guys remember a word called conjugate?
Yes.
What did that do? So I'm going to have to match identically the values within this numerator, but I will have to change a sign. Is that correct? In fact, it's the sign between what's represented right here as a first term and the sign of the last term. So I'm actually going to multiply the top and the bottom by the quantity of the square root of x, the square root of x plus 2, then plus 2. And in red, we're allowed to do that because the red part is another way of saying the number 1. I basically just multiply my fraction by 1.
So you don't change the sign under the square?
I do not change the sign under the radical. I only change it outside that radical between the two terms. That is very important. Now, some pieces of information to try to help us out. This is coming from my experience of doing this for a long time. I will multiply out the numerator. I will not multiply out the denominator. I will leave this alone. Just leave it as the product of two factors down there. But I will be multiplying out the numerator. So if I multiply out the numerator, then I end up with the limit as x approaches 2. And so if I take the square root of x plus 2 times the square root of x plus 2, what do I get? Don't everybody think at once. The square root of x plus 2 times the square root of x plus 2. What do I get? Isn't that just x plus 2? Take a square root of something times itself. Isn't that just the something? Is that how that works?
Oh, yeah.
That makes sense. Okay? So now I'm going to take this square root of x plus 2 times this plus 2. So I'm going to say that's plus 2 square roots of x plus 2. And then I will take this negative 2 times this square root of x plus 2 over here, because minus 2 square root of x plus 2. And as the last term, I'm going to take this negative 2 times that positive 2. And negative 2 times positive 2, last we checked was? So that's the multiplication of the numerator. In the denominator, I've got x minus 2 times the quantity of the square root of x plus 2 plus 2. So what's our next task?
You're combining like
So I have in the numerator here an x. Do I have any other x's in that numerator that are just x's?
that.
And then I have a plus 2 here. Do I have anything else in the numerator that allows me to collect with that plus 2? What is 2 minus 4? So those two are taken care of. Now I have a plus 2 root x plus 2, and then a minus 2 root x plus 2. If I had plus 2 of them, minus 2 of them, what do I get? They add to 0. So I'm only left in my numerator with an x plus 2. Guess how nice that actually is? That's not plus. I'm going to move it. I heard you. There. Does that make sense? So, mathematicians, what did we multiply and create right here?
Okay.
We actually made a perfect factor. We made a 1. It's a factor of 1. We did that earlier with our algebra and our factoring. We wanted to make those 1s. We made another 1. So then this is equal to the limit as x approaches 2 of 1 over the square root of x plus 2 plus 2. And that's obviously 1/4. What do you mean, how do I know? I plugged 2 in there for x.
Okay.
What's 2 plus 2? 2 plus 2 is 4, right? What's the square root of 4? What's the 2 over there? Is that 1/4? Do I need to show that, steps?
No.
Are we good with that?
But I love that you said obvious.
You don't like that term, do you? All right. So this is another specialized thing that happens if it fits in the category of a square root in the numerator and you get something undefined. You can rationalize the numerator as a process to try and get to a limit that we can evaluate. And there's that value. Guys, if you go back to that first day of limit homework that we had, you're going to find a problem somewhat like this. Almost exactly like this, I think. And you're going to find that that was probably the answer your chart showed you to that set of homework. I wasn't just picking those problems out to be giving you odd problems. I actually had some thought in mind of why you were doing those problems. You might want to go back and look back over that first set of homework and then just plug numbers in and see if things happen like we're showing you here.